So, did you know that the moon looks different from Earth, northern and southern hemisphere? Obviously, you can see the Earth if the moon is here. So, if a person is looking from the northern hemisphere, he will be looking on this part of the moon. But when a person is here on the southern hemisphere, so it will be looking at this region of the moon. So now we look at the moonlight. So when the sun is here, so we can't see any moon. So once moon is moving here, then you can see this is the full moon. Then again going back. So obviously we are looking at only the red part. So now you can see the moon is becoming small and small. Also, they are testing some new technology on this gravity, and I hope they have been doing much more on the surface of the moon. So just to make you sure that moon is only the celestial body in our solar system other than the earth on which the human have set foot. There's some other. Hello and good day to all of you. So in this video lecture we are going to learn about the moon and its formation and what are the theory behind the formation of the moon. And also we'll look at some comparison of the moon with respect to its size, atmosphere, and the magnetic field of the moon. So before starting the lecture, so we have some learning outcome for this chunk of lecture. So the first learning outcome is to learn about the formation of the moon and the theory behind the formation of this moon given. And the second objective or the learning outcome is to know the many interesting facts about the moon, such as their atmosphere, temperature, and a lot of things we are going to discuss in this lecture. So obviously we are thinking about how did our moon form. So there are some theories which has been given. So we are going to discuss as well. What has been happening so far? So I mean the formation of the universe, the solar system, and the formation of the moon. So we are going to discuss each and everything. So as I mentioned, we are going to discuss about the theories of the formation of the moon. So actually the moon is a sister world that form in the orbit around the earth as the earth form. So there are different theories which was given. So the first theory which was given is a capture theory. So according to this theory, so the moon was formed somewhere else in the solar system and then it was captured into the orbit of the earth. And the second theory, which is the fission theory, it states that the earth moon is actually the part of the earth. So when the earth spun so fast that it spun off the moon. So in this figure you can see. So actually this moon was the part of the soul of the earth, and when earth was spinning so fast, so it came out from the earth material. So then it's come into the orbit. And the third theory is condensation theory. So it states that the moon and earth condense individually from the nebula that form the solar system. So it's talking about the Big Bang. I mean, when it was Big Bang and nebula. So because of that time, so everything was extracted individually. So the earth and the moon was individual. Then it comes into the orbit of the earth. And the fourth theory, which is the giant impact theory. So what it states that actually it is the most widely accepted theory today is the giant impact theory. So what it proposed, so it proposed that the moon formed during a collision between the earth and also another small planet about the same size of the Mars. And when it's hit to the surface of the earth, so the debris obviously came out and it was in a disk of the debris. So it was rotating, revolving around the earth. And the later on, all the debris was captured by the earth. but only the debris which was the bigger, it came into being as a moon. And also some of the debris goes away from the orbit of the Earth. So only the moon was left because of this hitting the small planets. So that is the theory which is mostly accepted recently. So let's look at the size and some other interesting fact about the moon. So as I mentioned, the moon is the Earth only proper natural satellite, and it's at 1/4 of the diameter of the Earth. If we compare the size of the moon, so it's actually the size is almost equal to the Australia continent, Australia country maybe we can call, and it is one of the largest natural satellite. And if you look at the natural satellite in the solar system, so this is the fifth largest satellite in overall solar system. Obviously the four largest satellites are from Jupiter, and the orbiting Earth is an average lunar distance is 380,400 kilometer. So that is the orbiting Earth at average of the lunar distance. So also the diameter, as mentioned, it's 1/4 of the Earth, or we can call it quarter of the Earth, and it's look bigger because it's close to us. Even if you look into the sky, the moon and sun appears to be same, but because of the distance, the moon is near to the Earth and sun is so far from the Earth, so that's why it appears to be same. And especially when we have the solar eclipse or the lunar eclipse, so then you can observe these type of features, so that the moon is exactly similar size of the sun. So moon has no atmosphere, and there is a huge difference in day and night temperature. So actually the atmosphere protect the planet or object from the change of the temperature in day and night. So the temperature in the daytime at the moon is 127 degrees Celsius, and in the night is minus 173 degrees Celsius, which is a huge difference in temperature. So as mentioned, there is no atmosphere, so there is no water, no rain, no wind, and there is no cloud at the moon. So like everything else in the solar system, moon is also does not have its own light of or the source of energy. So it's shine due to the sunlight. So it will reflect the sunlight when we are looking at it. And there is no water on the surface of the moon. And if we're looking at the gravity of the moon, so the gravity of the moon is 1/6 of the Earth. So your weight would be 1/6 of your weight on the Earth. So let's say if you're 60 kg here, if you weight yourself on the moon, you will be 10 kg. So let's look at the first person who stepped on the moon. So just to make you sure that Moon is only the celestial body in our solar system other than the Earth on which the human have set foot. There's some other planet which we are explored like Mars, but still we don't have any human step on the other planets or the any satellites. So the guy name is Neil Armstrong, which was the first person to walk on the surface of the moon. He was the commander of the American mission Apollo 11, and he stepped on the moon on 21st July 1969. So let's compare some of the difference between Earth and Moon so you will be more clear about the understanding of the Moon. So if you look at the diameter of the Earth is 12,756 kilometer, and the diameter of the Moon is 3,476 kilometer. And as you know that there is a tilt of the Earth, so Earth is not like this, so it's slightly tilted 23 degree, but the Moon is tilted 7 degree. And the surface temperature of the Earth is maximum is minus 73 degrees Celsius and 48, maybe it goes up to 50 or 52 sometime like that. But the surface temperature of the moon is 127 degrees Celsius to minus 173 degrees Celsius. And there is a thick atmosphere and the mild greenhouse effect. Obviously, we are protected by the atmosphere around the Earth, but there is no atmosphere or no atmosphere on the moon. So it's a lots of water. As you know, 70% of the Earth is covered with water. But if you look at the moon, there is no water. There is some ice at the pool in shadows, but it's still not sure. So let's look at the magnetic field or the quakes. So the Earth has its own magnetic field, and also we have the earthquakes. But if you look at the moon, so there is no magnetic field, so there is no magnetic north and south pole and these type of things, because of the our inside is we are going to learn about the internal structure of the moon as well. So there is no magnetic field, and there is actually small moon quakes and the small offset core. So let's look at the rotation of the moon first. So the moon reflects the light from the sun just as the other planets, so it's not have the own source of energy, as discussed in the previous lecture as well. So the time it takes for moon to rotate once around its axis is equal to the time it takes for moon to orbit around the Earth. So it's mean we always look at the one side of the moon, which is called near side of the moon. So this keeps the same side of the moon as mentioned, so facing toward the Earth throughout the month. And obviously not throughout the month, but we still look at the near side of the moon throughout the time the moon has been formed. And does not orbit in equatorial planet of the Earth or elliptic. And the Earth's moon has the high angular momentum between each other. So this is a small video which is going to show you about the moon rotation and revolution. So I have been presenting here for 4 cases. The first one is moon without rotation. The second is moon with rotation, but it's a bit faster rotation. And the third case is moon with rotation, I mean the exactly rotation which moon rotates. And the fourth one is the moonlight, how the lights comes from the sun on the moon. So let's start with the first case. So in this case, we have the synchronous rotation. So let's say in this case, the moon is without any rotation. So over here you can observe moon is static. So the right side goes on the other side, then it comes to the same side. So in this case, moon is without any rotation. So the second case which we are going to present here is the moon with rotation, but it's a bit faster. So you can observe that the moon is with rotation. So from the Earth, we can see all side of the moon, like the right side, which is the near, and the other side is the far side. But obviously this is not the correct rotation of the moon. So the moon is rotating a bit slower, as I mentioned. So it's rotate once in the same time it takes to complete one orbit. So from here you can see this red part is appears from this side and it takes one rotation from here. So again we are repeating this step. So you can see it's actually rotating and revolving. So rotating and revolving time is same. How much time it takes from here to reach here? The same time it takes to rotate around its axis. So that's why only we see the red part, which is the near side of the moon. So now we look at the moonlight. So when the sun is here, so we can't see any moon. So once moon is moving here, then you can see this is the full moon. Then again going back. So obviously we are looking at only the red part. So now you can see the moon is becoming small and small. Also, we are going to look at more into details from this figure. So this is the figure which is actually, if our sun is here, so then the moon is like this, then it's going to be bigger, this bigger. And when we have the full moon, so this is actually the full moon, which is we can see on the middle of the month. But after the full moon, then it's going to be small, and suddenly disappear for one day. And now we look at the lunar month. So the lunar month is normally, this is the form of one new moon until the succeeding new moon. So if you look at an average lunar month, which lasts actually 29.53075 days, or it's actually around 29 days, 12 hours and 44 minutes and 2 seconds. Days are shorter of the calendar month. And do you know why is a day on the moon is same as the lunar month on the earth? It's because, like many other moons, not only the Earth moon but the other satellites, so like many moons in the solar system, the moon has the synchronous rotation. So it takes the same time to spin once on its orbit as it does to complete one orbit around the Earth. So that is the fact. That's why if you look at the surface of the moon, so that also have the same length of the day as we have the same lunar day on the Earth's surface. So did you know that the moon looks different from Earth, northern and southern hemisphere? Obviously, you can see the Earth if the moon is here. So if a person is looking from the northern hemisphere, he will be looking on this part of the moon. But when a person is here on the southern hemisphere, so it will be looking at this region of the moon. So that's why the moon appears differently from the northern and southern hemisphere, and obviously different from the equator as well. So now let's look at the appearance of the moon from all hemispheres, even North Pole, South Pole, equator. So these are the observation. So if we are looking at the person, if he is observing from the North Pole, so from North Pole you can see the moon will be appearing like this. So this is the first quarter, then this is the full moon, second quarter, and the end of the month. But when a person is looking from the northern hemisphere, so it will be appearing a bit more tilted like this one. So it will be like this, then this. The full moon is obviously same for all hemisphere. But if you look at equator, so you will be looking this way of the moon when it's a new moon. And when it's ending, obviously it will be same like this one. And if a person observing a moon from the southern hemisphere, so you can see the moon will be other way around. So it will be flipped. And this full moon then when it's end of the month. So more focus on the northern hemisphere. So they have a specific name of the moon. So when there is a new moon, then waxing crescent, and this is the first quarter, and the waxing gibbous. Then we have the full moon, waning gibbous, third quarter, and waning crescent. So this is from the northern hemisphere. So similar way we have from the southern hemisphere. So the names are from here is the name is actually the same, but obviously you will see the other side of the moon. So this is the new moon, then waxing crescent, first quarter, waxing gibbous, then we have the full moon, then waning gibbous, third quarter, then the waning crescent. So these are the some names of the moons when it appears from the north and south hemisphere. So if we compare our moon within the solar system, the natural satellite, so the moon is actually the fifth largest satellite of the solar system. So the first one is Ganymede, which is from Jupiter. Second is Titan from Saturn, then Callisto, then Io, then the moon comes in. And if we compare this all satellites from the Earth, so this is the size of the Earth, and other moons are smaller than the planets. So let's look at the formation of the moon. So as I mentioned, there is different theory about the formation of the moon. So but what we believe we have explained in the previous lecture, so you can refer to that lecture as well. So it's stated that the 4.5 billion years ago our moon was formed. So obviously the lunar rocks and meteorites all was formed together. So it's mean the age of the moon is 4.5 billion years. So let's look at the geology, or it's called the selenology of the moon. So if we divide the geology of the moon, it can be divided into two different parts. So by this color in this figure on the right side actually represent the elevation of the surface of the moon with different color. So it can be divided into two category of the rocks. So one of them is iron rich and the second one is magnesium rich. And also if we can divide these rocks into different years or the age, which is 4.3 to 4.5 billion years old rocks, and the other is 4.3 billion onward from the recent. So also we can look at the internal structure of the moon. So let's start from on the top we have the crust, which is around 52 kilometer thick. Then we have the mantle, which is actually 1205 kilometer thick. And then in the core we have the partial melted core, which is 150 kilometer thick. Then we have the outer core, which is 90 kilometer, which is liquid, and the inner core, which is 240 kilometer, which is the solid core. But if you look at the crust, so it is mostly made of the silicate minerals, which is generally an ionic compound whose anion consists of the predominantly of the silicon and oxygen atoms. So these representing actually the craters which we have here and the lunar trail. So now we look at the process what happens so far today, and what are the actually process that forms these type of rock minerals on the surface of the moon. So if you look at the geological age of the moon, so more than 3.7 giga annum, or you can call the giga year, which is 10 raised power 9 years. So there was actually argon 40 and argon 36 ratio was quite higher. So actually this ratio is cause of the degassing of the lunar exposure. So during that time we have a lot of volcanism here. So you can see when there's volcanism, this degassing phenomena happens, and there's a lot of degassing phenomena happen. So we are going to look at some of the rocks from these type of structures, and also the second effect for the solar wind. So because of the solar wind, there was implementation of wind gases and also implementation of argon 40 from the lunar exosphere. And also because of the heat of the mantle, there was some crackdowns because this is partially melted, plus degassing phenomena. So because of that, you can see these type of features was happening during that time. So if you look at the time scale on the lunar stratigraphy, so lunar stratigraphy has been divided into 5 general recognized period. So one of them is pre-Nectarian, which is the oldest time. Then we have the Nectarian here, then Imbrian. In Imbrian, we can divide into late and early Imbrian, then Eratosthenium, then finally the recent time we called it Copernican. So also I have explained here, so this is actually the time when it was 34.5 billion year to around 400 maybe 3.9 billion years. Then you can refer to all time scale which is given below. Actually this is in million of year before the present. Also we look at the topography of the moon. So you will be thinking either the surface of the moon is flat or topography it is high and low. So if you look at the topography of the moon has been measured by methods of laser, altimetry and stereo images analysis, including the data obtained during the Selenology missions, which is actually the Apollo mission as well. And the most visible topographic feature is a giant far side South Pole Atkin Basin, which was actually one of the crater. It's the largest crater on the surface of the moon as well. So which possess the lowest elevation on the moon, and the highest elevations are found just to be to the northeast of the basin. So if you look at this is the near side, which actually we look at the moon all the time, and this is the far side. So actually I'm referring to this point, so which is actually the basin, or it's a larger crater. We are going to learn this about crater in the next video lecture as well, or you can refer to this how the crater are formed and what are these craters. And also if you look at the scale of the legend, so you can see this is from -6 kilometer up to 7 kilometer. So the highest topographic feature on the surface of the moon is 7 kilometer. Obviously we don't have the sea level, but it's a different level which has been defined on the average surface of the moon. So based on that, it is the deepest part is 6 kilometer and the highest part is also 7 kilometer around. But in some other places you will found some more deeper, like 8 kilometer. It depends on what are the reference point. So there is another volcanic feature which is called Marius volcanism. Marius volcanism is actually the vast lava plain within the Imbrian Basin on the moon, and it is actually one of the larger crater which I mentioned before, and in the solar system actually. And the Imbrian Basin formed from the collision of a protoplanet during the late heavy bombardment. So over here you can see this is the Imbrian Basin. So and the basaltic lava later flooded the giant crater to form the flat volcanic plain seen today. So if you look at today, so it appears to be very flat, but this is because of the lava flow on the surface of this basin. And if you look at some of the features, so you can see this is the highest peak, which is shown here, southwest Marius Imbrian. And also lunar volcanism. So as I mentioned, there is some moonquakes, and also it's volcanically active. So on the left you can see these are actually the flow of the lava, which is one of the example here shown. And on here this is the Marius Hill. So this is the highest point which is normally known in the surface of the moon. Then there's some rocks which has been collected from moon surface and during the Apollo mission. So This was the rock which was taken from Apollo 17 mission. So over here, these example actually shows the crystallize from the lunar magma, because these are primarily of the mineral plagioclase, which is shown here, and also the light gray color, which is the plagioclase, this one light gray, and the greenish is tractolite, which is shown here on this side. And in below rock sample, you can see this is the anorthosite, and this is also formed in the magma, and for this there is no water needed. And plagioclase feldspar also does not need water, I mean, when it's forming. So it's mean that it was formed when the magma was separated. And there is another rock which is the polymix breccia, which is on the left side, and on the right side is impact melt plus class. So these are taken from some Apollo mission 16, and this is also from 16. Then we have some lunar basalt. So normally these rocks are typically the lunar volcanic rocks. So you can see the degassing phenomena happen on this rock. And it was collected from Apollo 15 mission. And both are 3.3 billion year old basaltic, similar to those produced by volcanoes such as Hawaii on earthquake. And the lower image, which is over here, shows that it contains some types of gases, possibly carbon monoxide, which form the round holes known as vesicles on the surface of this rock. So you can see this is rounded. So let's look at how and why the moon craters are formed. Craters on the moons are caused by the asteroid and meteorite collision with the lunar surface. In the figure A, you can look at, so this meteorite is coming in the orbit of the moon and trying to hit on the surface of the moon. So once it hit to the surface of the moon, so you can see it can go, because of the weight, I mean, depends, if it's larger then it can produce a bigger crater, but it's smaller and can create a smaller. When it goes inside, I mean, hit to the surface, then you can see this all surface materials goes out, and it can form like a syncline or the basin feature. And if you look at the how many number of craters we have on the surface of the moon, so there are thousands of the craters. And unlike the Earth, the moon has no atmosphere to protect them from impacting this body. There's a lot of meteorites which can comes into the orbit of the Earth, but because of the atmosphere, it can protect, and it can reduce the speed of the meteorites. So let's look at the count how many craters we have on the surface of the moon. So from these figures, you can look a number of craters you can observe on the surface of the moon. So lunar craters are impact craters on the Earth moon, and the moon surface has many craters, all of which were formed by impact of the meteorites. And an International Astronomical Union currently recognizes 9,137 craters, and from which they have named 1,675, and they have named and dated, and they have calculated the size of these craters. So I'm going to show some of the example. So these are prominent crater on the surface of the moon. So I'm not going to show or not going to call each and every name of the crater, but just to look at here the summary, it is from Wikipedia. So you can see this is the red dot actually shows the placement of these craters. And in the parentheses, you can see this is actually the size of these craters. So you can see 131 kilometer, 231, and up to, then it goes here. So in these two figures, we can see we have the biggest crater is 231 or 301 actually. So 301 kilometer. So it's quite large crater we have on the surface of the moon. So if you look at the biggest crater on the surface of the moon, so it is actually situated in the South Pole, which is Atkin Basin, is actually the immense impact crater on the far side of the moon. So it is not at the near side which we look at the moon, but it is the other side of the moon. And it's roughly 2500 kilometer in diameter and in between 6.2 to 8.2 kilometer deep. So as I mentioned, some places you will find 8 to 9 kilometer deep. So this is actually the place where we have this one. And it is also one of the largest known impact crater in the solar system. So this is actually the largest in solar system, whole solar system, what we have explored till date. So let's look at the history of the Apollo program. So Apollo program was designed to land human on the moon and bring them safely back to the earth. So there were 6 missions till date have been performed. So Apollo 11, 12, 14, 15, 16 and 17. So these were actually the mission which was planned for sending the human to the moon surface. Obviously before that they had some mission which was unhuman. I mean, there was no human being involved. So Apollo 7 and 9 were actually performed for looking at the orbit mission of the Earth, and it was did not return lunar data, obviously. So here is some figures which is from Apollo 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and Skylab 1. So these are the craft or the source of the Apollo missions which has been used so far. So if you look at the history of the Apollo mission, so as I mentioned, there's a number of Apollo missions we have. So this is actually a summary till today. So as I mentioned, there were some Apollo mission before human activity. So Apollo 4 and 6 of the launch vehicle and commanded the services modules to demonstrate the adequate of their design and certify safety for man. And after that they have improved it. Apollo 5, so this was also a flight demonstrate adequacy of its design and certify its safety for man. So I mean they was testing the flight which actually going to take a human. So they send it, they want to observe either it can go and come back safely for human carrier. And then Apollo 7, 8 and 9. So this Apollo 9 mission was actually the manned flight of the complete lunar landing mission wheel in low Earth orbit to demonstrate operability of all equipment and insofar as could be done in the Earth orbit to perform the maneuvers involved in the ultimate mission. Then Apollo 10, it was actually a complete mission except for the final descent to and landing on the lunar surface. So actually the human was involved, but they didn't land on the surface of the moon. Then finally the Apollo 11, which was the first mission. During that time, this was human involved mission. Obviously there was also human involved, but this was the mission where they step on the surface of the moon. So it was in 1967. So the initial lunar landing mission, so this is called. Then after that, obviously they have improved it. So in Apollo 12, 13, 14, so this was a precision manned lunar landing demonstration and systematic lunar exploration. And 15, 16, and 17, so there was extensive scientific investigation of the moon, as I show you some of the rock sample from Apollo 15, 16. So we have collected some of the rock samples from here for study the geology of the moon or selenology of the moon. So not only the geological side, but obviously some other factors which was included during the study, scientific investigation of the moon on the lunar surface and from the lunar orbit. So if we look at the places where Apollo mission was done, I mean, at which place either they went on the one place all the time or they went to the different places. So just to highlight the Apollo mission, which is from this figure on the right side. So the satellite was landed. So the first mission was 11. So they landed here, then 12, 14, 15, 16, and 17. So these are the places. So all these sites are near side of the moon. So all this mission was done on this one side of the moon, not the other side. So now we look at what's the future plan for the space. So NASA will continue that work by moving forward to the moon with the astronaut landing on the lunar south pole by 2024, so which is next year hopefully. And NASA is also implementing the President's Space Policy Directive 1 to lead an innovative and sustainable program for exploration with commercial and international partners to enable human expansion across the solar system. So on the right side figure, this is actually the artistic's concept which shows the NASA Gateway in lunar orbit. So this is actually the NASA Gateway in the lunar orbit, and we can see the Earth from here. So the power and propulsion element will be the first component to launch for the placement near the moon, which will be this year soon, 2022, with the additional element launching the subsequent year in the future as well. And also there was a recent Apollo mission which was happened in 2018, and in that mission actually they stay for a week long on the surface of the moon, and obviously their next plan is to stay 45 days outpost. So during this time what they did, actually they set up for the first time full-fledged habitat on the another world, which is moon. And also they have tested advanced space suits, I mean the suits which they wear, and also the rovers, which is these I mean the cars or rovers we can call it, and try out the methods for protecting and exploring from deadly radiation which is coming from the sun. Obviously they cannot protect because there is no atmosphere on the moon, and also they have gauged the effect of the absence of normal gravity. Obviously the gravity of the moon is 1/6 of the gravity of the earth. So also they are testing some new technology on this gravity, and I hope they have been doing much more on the surface of the moon. So there is much more information and knowledge about the moon. So you have to think about yourself when, if you are on the moon, what do you think or what you will feel? So please share your comments in the chat box or in the comment bar. And with that's all, thank you so much. And I hope you have learned something about the Apollo mission. And if you want to learn more about this, so please visit the NASA website And obviously, there is much more information given for you. And with that's all, thank you so much and have a good day.